Okay everyone, today we're going to be doing a great follow-up lesson to our one-step equation video. We're going to be looking at two-step equations, which really just, as it sounds, adds another step to our solving for variables. And then I would like to start getting into multiple step equations, which definitely you'll see in late middle school and pretty much throughout high school. We'll also talk about inequalities in another video. So this is another video that I highly suggest that you either watch my videos on integers first, and definitely watch the video on one-step equations before you watch this. I have some great techniques as usual. If you could, do me a favor and subscribe and hit that notification button. It'll help me out. I hope you enjoy, and I hope it's helpful, and please leave a comment. Alright, so let's look at a couple computation problems first before we try and apply some real-world scenarios to our problems here, okay? What I do want to say is that when we're looking at two-step equations or even multiple-step equations, it's really combining what we've learned in the past. Everything with math is really scaffold. But with the one-step equations, two-step equations especially, we're looking at PEMDAS in reverse. So what that means is you're either going to add or subtract to solve, all right? And then the very last thing is that you're going to divide or multiply to solve for your variable, all right? So with that being said, let's take a look at the first one here. All right, and there are instances where you could get a fraction or a decimal as an answer, as you'll see today. So we have the 4. We want to get rid of that. So we're going to touch anything with the variable last. All right, so we're adding 4 to both sides. Remember, we're thinking inverse operations. We have 10, 15 over h. So already, if your mental math is on point, you're going to be able to tell that we're not going to get a whole number here, which is completely fine. So since it's 15h, we know that that's multiplication. We're going to divide to solve. So we're left with 10 over 15, but as we know, we want to reduce all our fractions, so 5 can go into both the top and the bottom, giving us a result of 2/3. All right, this one here, we have plus 6, so we want to get rid of that by subtracting. Once again, we want to touch our variable last. All right, so we have 5z, we bring down what's left. All right, since the signs are the same, we're going to combine them. So remember our subtraction and addition of integers video if you need to go back to that. So we get negative 26. We divide by 5. Okay, now we have an improper fraction, so we need to fix that. All right, still going to remain negative. 5 goes into 26 5 times with 1 left over. So we have negative 1 or negative 5 and 1/5. Okay, this one's a little different because we can see that over here we have a division problem, all right, whereas these ones were all multiplication. All right, so we're going to still follow the same procedure. We're going to get rid of this 9 by adding. All right, so we add 9 to both sides. All right, that cancels out, so we're left with d over 14 equals 14. All right, what makes this different is that whereas before we were dividing to solve, well, it's showing division. So we want to multiply to solve. So we're going to multiply by that number that's paired with the variable. All right, so 14 times 14 is simply 196, and that would be our answer for that. All right, the last one here obviously is much more difficult than what we've seen in the past. But we're still going to take the same approach. So we're going to mess with the negative 9p last. So this is a positive 3/4, so we want to subtract. All right, I know we're dealing with fractions, and it's not always the funnest thing to deal with, but we'll muscle through here. So we got to find a common denominator. We can tell that we're going to add, because both of these are negative, giving us a negative result. So 20 is our common denominator. All right, 5 times 4 got us 20, so we multiply the same on top. 5 times 4 gives us 20, so we multiply on top, giving us 15. So we end up getting negative 27 over 20. All right. Now we're going to divide by negative 9. So when we divide by negative 9 over here, this can be rather difficult. So when we do so, all right, when we do so here, we're going to see that we're going to take the flip of this. All right. So I'm going to erase some stuff over here so you guys can see. All right, so we have negative 27 over 20. Remember our keep, change, flip. So we're going to change this to multiplication. We flip this upside down. So we can cross cancel 1, 3. So they're both negative, so we're going to have a positive result. Remember the party hat rule. So it's positive 3 over 20 would be our answer for this one. Definitely a much more difficult problem here. So if you need to rewatch the video, go for it. It'll definitely help you out, but this is a little bit more difficult compared to our other ones here. Okay, so this is a great real-world application of two-step equations. I get a lot of people saying, "No, you never use algebra in real life." Well, this is a prime example here. All right, so the first thing we want to do is set up our equation. So it says a taxi charges $1.50, all right, plus a fee of 60 cents for each mile traveled. If a ride costs $5.40, how many miles was the ride? So the $1.50 is a flat rate. We know that we're going to get charged that no matter what. Okay, so we can write that down. All right, that is not dependent upon how many miles that we ride. We also know that the total cost is $5.40. Okay, all right. What could change is the 60 cents dependent upon the miles. All right, so what's going to change? Well, we multiply however many miles that we travel, which we actually are trying to figure out. All right, so there are some decimals involved here, which is completely fine. Remember, real life isn't all whole numbers. So we're going to approach it the same exact way. All right, we're going to get rid of this $1.50 first by subtracting. All right, when we subtract over here, we end up getting $3.90. All right, and then we have 0.6 or 0. I'm sorry, a 0.6 or 0.60. You don't really need that last zero though. We're going to divide by 0.6. Just know that we're looking at miles here. 3.9 divided by 0.6 ends up being 6.5 miles. So how would this work in real life? Well, if you want to make sure that you were charged the right amount, this is the approach that you would take. Now, do you always think in terms of algebraic equations? No. You might think of it differently, but the setup or the outcome is going to be exactly the same. All right, so I hope this really was helpful for you. Okay, so that was our video on two-step equations. As I said before, you definitely want to watch the video on one-step equations and all our videos on integers to really get a good grasp on what's taking place here. In essence, as I said, what you're really doing here is taking the PEMDAS rule and going in reverse. All right, so as you saw, you're either going to multiply or divide at the very last to solve for your variable, because you can see that the multiplication and division is paired up with your variable. I would highly suggest to rewatch the video. If there's anything that you'd like me to explain further, feel free to leave a comment below. If you felt that it was helpful, please leave a like. It'll help me out. Otherwise, I hope you have a great day, and I hope you're successful with all your work.